Okay, if I can get your attention, we're going to go ahead and get started. All right. One more audible, just for anyone that missed it. We're being Semper Gumby today, and we're flexing to accommodate interesting technical discussion, perhaps not with all the speakers you intended. So for anyone that's in the room that came here for cybersecurity, that's not happening. The Admiral could not make it. And for those of you that are in the room for future ship programs, I'm all you have. So we're not going to talk frigate. We're not going to talk LXR, unfortunately. I'll try to get those rescheduled at a future ASNE event because I think there are things that we want to talk about to industry. I could talk frigate, but I'm told not to. And LXR, I'm not the guy to talk to it. But there's a lot to be said and a lot that I think industry wants to know. So what I'm going to talk to you about today is kind of my view of what's going on in the world, and I'll tell you who I am. I'm Kerry Filling. I'm the director for NAVSEA 05D2, Surface Combatant Engineering. So for any of you that don't know NAVSEA well, we have 5 divisions in 05D, surface ship design. D1 is early stage concepts. D2 is surface combatants, excluding amphibs, so all the surface combatants that have guns and missiles, right, that shoot. D3 is the amphibs. D4 is T-ships, and D5 is all of the in-service ships, right? So that's how we're organized. All of the folks in 05D are either ship design managers at the GS-15 level, deputy ship design managers, design integration managers. They're supported by a vast team of contractor support here on M Street, kind of the M Street family, as well as folks at all of our Navy labs. Obviously, a lot of close association with Dahlgren, Carter Rock, NAVSES, Crane, right, the ones that are closest to us. And in fact, Jeff Merlino is working furiously at the table to come up with, show you some of the, how we do machinery arrangements on Flight 3. So for anyone that saw Flight 3 yesterday, I'm going to tell you some of the same stuff, but hopefully I'll give some more insight. My background, I spent 16 years as a contractor working for what was a small company called Advanced Marine Enterprises. That became Nichols Advanced Marine, and then ultimately CSE Advanced Marine. In 2009, I was insourced to the Navy. I came on board to be the concept manager for Flight 3, so I did that for a year. And then I served 3 years as the ship design manager. And of course, I now manage the ship design manager who works on that program. So I think of Flight 3 as my baby. I didn't develop the slide deck, so you're going to see me probably fumble a little bit with the slides, but I know the material. The program right now is run by Captain Mark Vandroff in PMS 400D. Rich Sturgis is the flight upgrade manager, and Walton Mebin is my Flight 3 ship design manager. Again, my scope for my team encompasses all of the design and engineering for all the surface combatants, including both variants of the LCS at present, both the Indy and Freedom. And my Freedom team is up, engaged with the program office and Marinette this week, up in the lovely weather in Marinette. My team is also involved with evolving the LCS class into the future frigate. We have both flavors of DDG-51 destroyers, the Flight 2As that are in construction now. I was up at Bath last week, actually up for the Zumwalt, the other destroyer we oversee. Bath was a lovely minus 21 degrees last Tuesday. And I'll tell you that the folks in Bath and the folks in Marinette do not stop shipbuilding when the weather gets cold and snowy. So I give you guys credit for being equivalent to our northern shipbuilders and not stopping when the snow starts to fall. But on that note, being up in Bath, the DDG 115 Rafael Peralta is sitting proud on the ways. We have the DDG 1000 floating in the water, the Rafael Peralta sitting between her and DDG 1001. So it is nice to see DDGs coming together at both Ingalls and Bath and seeing those grace our waterfront again. So we have 2 flavors of destroyers in active construction. I think that's all on 05D2. What I want to show you first is a video to give you a sense of AMDR. This wasn't shown yesterday. The government has spent a long time evolving the future radars. There was a large group of us that spent time on the Cobra Judy replacement, which eventually became the Cobra King radar in TAGM 23. That was a joint effort between Raytheon and Northrop Grumman. That family of radars then grew into a competition between Lockheed, Raytheon, and Northrop for AMDR. And having been through all of the program reviews with those three companies, credit to all three, it was a fierce competition. I'm sorry to say for Northrop and Lockheed that Raytheon won. For those of you at Raytheon, congratulations. AMDR is quite a formidable radar. It's going to take our future destroyers and make them far more capable than the ships equipped with SPY today. And what you'll see, hopefully today, is a story that shows you that even though we call the Flight 3 a destroyer, it is really more capable than any of the current cruisers in the fleet, right? It may not have quite the missile count, it may lack one stern gun, but with the radar and the evolution of the Aegis combat system, you have quite an effective platform to go after ballistic missile defense, a mission that the Navy inherited for the nation to protect ourselves and our allies. So the video I'm going to show you is from Raytheon. It gives you an idea of what a modern radar has to do to combat multiple threats. So if we run the AMDR video. No, AMDR. We can look at BLS later. It should say Raytheon. Yeah, that's it.
This one here?
Yep. So that's the Flight 3. Shown with both S and X band, and we'll talk about that radar evolution. S is a better volume search, X is a better discriminator. And of course, like most Navy days, the bad guys always show up. You'll note that the S-band radar is better for volume search and high targets. The X-band radar is better for clutter and littorals, low targets. And obviously the Flight 3 doesn't have to be the shooter. I apologize for the shameless plug for all the Raytheon products, but they make good videos. All right, so we're going to talk now on Flight 3 and the evolution of the destroyer. Here's the agenda. I won't read it to you. And by the way, the AMDR is now called SPY 6 for those of you keeping track. Okay, so why did we go about trying to evolve the destroyer? I think you heard a story from a lot of our plenary speakers about the fact that we had a future cruiser that was too large and too expensive. And so we did a radar hall study within the government to look at the 1000 platform, the 51 platform, look at the combat systems, and look at the radars that were available to figure out how the Navy could best provide missile defense quickly to the fleet. And the idea was to get the most cost-effective, most affordable solution fielded as quickly as we could, because the threat is evolving faster than we'd like to admit. So after a lengthy study, the solution was decided we wanted to evolve the Flight 2A destroyer to use the formidable Aegis combat system and put the AMDR on board. There's a two-prong approach to that, and you'll see that evolve. The first 12 ships in the Flight 3 are planned to have the S-band AMDR radar with a Spook 9B. You might recognize the Spook 9B if you drive along the Norfolk waterfront. You'll see the large kind of billboard-looking radars on all of our LPD ships. They stand out quite proud. It is a phased array radar, but it's a rotator. It is two-sided, so it has a pretty good refresh rate, and there's actually a lot of evolution going on in Spook 9B to be able to do periscope detection, mine avoidance. So the later ships are planned to have a phased array paneled X-band radar, which you saw in the Raytheon video. That won't be on the first 12 ships. The thing that is maybe hard to see in the lower right-hand corner is the capability of SPY versus AMDR, and I can't focus on this enough. This is an exponential increase in the ability of our ships and their radar capability. It's a 30 times gain over SPY. So you see there that AMDR will detect an object half the size at twice the distance, right? It will support over 3 times the number of missiles in flight and over 6 times the amount of objects in track. So we're talking an exponential increase in the ability of that destroyer to be able to track multiple targets, to engage multiple targets. And so again, when we talk about what is a cruiser, what is a destroyer, these ships in the future fleet will function for the near term as that future destroyer. With that said, does the Navy still desire to have a larger ship with a larger array? Certainly. We always want more capability for the fleet sailor. But this was the fastest way to get the capability to the fleet. And so again, 2 new radars. The Spook 9B will come on earlier in the evolution, followed by the SPY 6 in the FY16. The first Flight 3 right now is FY16. Starting in 17, it will be upwards of 2 Flight 3 destroyers a year. So what you're seeing here is the design review progression. Basically, preliminary design was complete. We've gone through gate 4 and 5. And I should say, to some of the folks in the room credit, there was 3 years of flight upgrade study in advance of PD. So although it looks like this is a recent evolution completing in December of 2013, just over a year ago, this really started in December of 2009. So we've been doing the design and the engineering, and again, folks like Jeff and his team have been doing arrangements work with all 3 radar vendors over the flight upgrade study, and then we down-selected to Raytheon and now are carrying 1 design forward. It was a modified acquisition process, so we did a gate 3 and then a gate 4-5. We've got DAB approval to proceed with detailed design that happened in June of last year. We'll have to go back and get DAB approval to proceed to construction. So one thing you won't see here is talk of particular lettered DAB. So these are simply, we've been given a tailored acquisition from leadership, understanding how much evolution's been done on Flight 2A, realizing that you already have an ACAT program in the radar going through its own gate reviews. So again, merging those together along with the continuing evolution of the Aegis combat system. Again, we do reviews internally. System functional review just happened in October of this year. That's where we get together with all the tech warrant holders in the NAVC world, with the captain, with my SES, Robin White, and review where we are, look at technical risk. You'll see the risk cube there. We track risk. Again, we set up this program to not have a lot of risk. It's more evolutionary than revolutionary, but I think the capability that the fleet will get in the end is quite revolutionary. So let's keep going. All right. So where did we start the process, right? There's a challenge we have in ship design today is that we don't get to do a lot of clean sheets designs. So we're evolving a lot of our platforms, right? We're doing that with the frigate on LCS. We're doing that with DDG. So we kind of have to know where we're starting from. And again, one of the things that the Navy does very well in the DDGs is accommodate rapid change in technology insertion of mature combat systems, right? And so we evolve these ships every few years. The Flight 3s are the last of a multi-year procurement, the last 3 ships of a multi-year procurement. So this is the start of that procurement. And I'm going to fire the laser here, so everyone duck. No? Which button do I need, Paul? I see it, I think I got it. There we go. Okay, so I'm going to shoot this way. If you guys can look this way. I'm going to walk you around the ship. So one of the things that was said in an audible yesterday on these slides is the ACB TI evolution is sliding a little bit to the right. For those of you that have not lived the religion that is Aegis, the ACB is the software change, the TI is the hardware change. So as ship designers, we tend to care a little more about the TI because that's what we're talking about, the racks, the servers, right, the power conditioning equipment. The ACB is the software. But the story you should take away from this room is that when we're finished with baseline 9 Aegis, both in back fit and forward fit, all of our Aegis BMD ships will have the same BMD capability. And ultimately, in the Flight 3 destroyer, the CIC will have the same number of consoles as a cruiser today in the fleet, as a BMD cruiser today in the fleet. So again, we call it a destroyer, but it brings great cruiser BMD capability. So let's walk around the ship. Again, evolution in the VLS software to do BMD. Again, the Spook 9B radar. It doesn't look that large sitting up on that big mast, but it is a pretty big weight high in the ship. And again, this is being done in the first 12 ships versus the 3-face X-band that was shown in the video. Again, a lot of changes you're seeing for BMD 5.1. The multifunction towed array is going to be installed in line. We do that at PSA work now. Upgrades to CIC, again, upgrading Aegis. So again, not a lot of radical change in the FY14, more of an evolutionary combat change. So now this is where it gets a little more complicated. We evolve the Aegis software to accommodate AMDR, and that's no small feat because we're now integrating two radars into the suite, both the Spook 9B and the new S-band radar. The array doesn't look that much larger, and probably passing a Flight 3 at the pier, you might not notice the difference. If you saw any of our earlier Flight 3 briefs, we often showed the array as a square because each of the 3 vendors populated that array in a different fashion, so the shape varied a little bit by vendor, so we tended to show a square. The good news is with the array going forward, there was concern that the array was going to push higher in the ship. For those of you that have been on a current Burke, particularly a Flight 2A Burke, the view from the bridge wings has decreased. I stood on DDG 107, the Gravely, and the new, he was the prospective CO was on board. And he had been on Flight 1s and Flight 2s, and he looked aft and he said, I can't see the helo. And what he meant was that the hangar that's on the Flight 2A obviously blocks some of the visibility helo. When it ultimately lands, all you see is the tail light and the top of the rotor. The other thing is the arrays have grown in size over the years. Spy 1DV is a much larger array. This array is larger still. The good news is the box that blocks vision aft with the aft arrays and the boxes that block vision forward that you basically can rest yourself on the bridge wings are not growing any taller. So those of you that have been on a Flight 2A, the visibility from the bridge wing will be the same. The arrays aren't moving taller. It's something we did look at seriously during the flight upgrade study. The other thing you'll see is we grew the enclosure here on the starboard side. For those of you that are familiar with the DDG 91 and Follow, we put a remote mine hunting system on those ships. That's the same area. What that does is double stacks the boats forward. Again, something we did on those ships. Whoops. There we go. Put the laser button close to the slide advance button. So there's the boats double stacked. But we had to grow volume there, largely because of the growth in the systems to accommodate the radar. We'll walk you through that. The other thing you'll see aft is the full load displacement enhancement system. We'll talk about it later. If you say it out loud, it's floaties. We say floaties because we don't like to say blisters in the Navy. We had some bad experience in the Midway with blisters. But what we're doing is really fairing the lines aft. making the ship fuller. So if you approached a Flight 3 and it was next to a Flight 2A, you might notice the stern, the transom looks a little wider. All of that line fairing is done above the static water line. It's done for damage stability. So it shouldn't detract from the ship's performance through the water, but it does significantly enhance its ability to accommodate weight growth and damage stability cases, so we can increase the displacement to 10,300 tons to allow for service life. So one of the things that I'd want everyone to take away from any presentation you hear from the NAVARCs and O5D is that service life is important. And we shouldn't confuse margin for design or margin for construction with service life allowance. And you'll hear us talk about service life allowance later in the brief. We're talking about service life allowance for power, for cooling, for area, for volume, for weight. And why that's important is these ships have to continue to evolve to face the future threat. And if the original DDG-51 Flight 3 designers, and I'll give a shout out to Andy Summers and a few others along the way, Pat Crow and some of the other SDMs, if we hadn't kept that margin, service life allowance in the ships to allow for the growth, we'd never be able to deliver a Flight 3 today. So it's very important, and folks on both sides of the river tend to forget that, and people don't think that service life is really a capability, but it really is, because it allows us to face that future threat. And that's one of the things that we've struggled with in all of our combatants is obsolescence, right? There's a reason we retired some of the cruisers early, right? Because we couldn't face the future threat. It couldn't accommodate the combat system growth, the weapon system growth we wanted to put on those platforms. You'll see more details, but the big changes to AC and electric plant. Again, all the energy and the AMDR you'll see occurs at the face, and so we need to cool that. And it is a power-hungry radar, as are most of the future radars. But again, with that power comes great capability, and we'll talk about the details there. The other thing we're doing is increasing the inner bottom scantlings. That really has two effects. One is it better accommodates whipping response for the ship, so structural response to nearby underwater explosions. The other thing, it helps us with KG, right? So we kind of get strength for the hull, and we get the added benefit of KG. When you're trying to put radars aloft, it's good to put weight low. The other thing you'll see there is HFP going into the modules, and that's replacing halon in the modules. We're doing that because the MT5 enclosures are coming with that from DDG-1000. And again, the story you'll see throughout this brief is that there's a lot of sharing of parts and pieces between LHD-8, DDG-1000, and the Flight 3 destroyer. We're trying to ensure equipment commonality for the fleet for ease of maintainability, crew training, and keeping these ships for their life. So how do we evolve any existing design? We do ECP packages, and this is the way we've evolved the Flight 2As throughout their life. So we deliver to the shipyard, and we'll show you a complete list here of all the changes. Again, the big things we're doing are the new radar, the electric plant, the AC plant, habitability flow down. One of the things we came away with from the Admiral Belisle report is that we need to maintain our cruisers and destroyers in a better fashion. There was a trend, and I don't have it in the brief, but you can track the trend of the manning level came way down on these ships. We found out that our spy radar were not as well maintained as they should be, and suddenly, thanks to the Belisle report, we're increasing that manning. And that's a challenge, because of course, obviously from a cost standpoint, you want to not have less sailors on board, but they are required to do maintenance, so maintenance is important. And of course, structures. I think we'll talk more about this, so we'll keep moving. So this is a good pictorial of where all those changes are occurring on the ship. You've got the 4160 volt AC plant, and we'll talk about that. Essentially, the DDGs, if you haven't been on board, are a 450 volt plant. A lot of folks like to call 4160 high voltage. If you talk to any of the electrical engineers, they say that's not high voltage, 13.2 is. So really, 4160 is medium voltage, but you'll hear a lot of folks refer to it as high voltage. So our ship will now have generation at 4160. It's provided to the radar at 1,000 volt DC. It's then stepped down to all the 450 distribution. So the intent was to maintain the 450 distribution aboard the ship and keep that as is. You've got the the power distribution modules and the power conversion modules. The PCMs basically convert the 4160 to 1000 volt DC. This is a kind of a legacy interface that we provided from DDG 1000, from CGX. It is an evolved power conversion module. You also hear it's an evolved gas turbine generator. So again, evolution of what we have on DDG 1000. You see the 4 arrays. You see all of the SPY equipment, including large cooling equipment units. One of the challenges with these phased array radars is SPY generated all the power off array, right? And that was fed out through waveguides. I'm sure many of you have scars on your head, much like I do, from banging into those waveguides in the array rooms. No one ever liked when they got bent, because then we had arcing and problems with SPY. This radar is different than that. The energy doesn't get generated off array, it gets generated on the array. So all the power, all the cooling have to go to the array face. One of the challenges with that is we want our ships to still be viable in the North Atlantic, and so chill water on the face of the deck house tends to freeze. So we now have to pump propylene glycol. We used to pump ethylene glycol through the arrays on Cobra King. EGW is better known as the Prestone. It's considered toxic, so now we do propylene glycol. That's the RV antifreeze that many of you put in your RVs and boats and things like that. So again, have to pump that through the array to keep it from freezing and to keep it cool in hot temperatures. And those cooling equipment units are really an evolution of what was on 1000. One of the things you're going to find, a continual story, is making things fit on the Flight 3 from 1000. For those of you who've walked 1000, it's a very voluminous ship, much bigger than a Flight 3. Things that fit easy on 1000 have to be tailored for the Flight 3. You see the full load operational displacement enhancement system, floaties, the starboard enclosure, the AC plants, and the inner bottom structure, and we'll talk more on each of those. So this is the overview of the SPY-6 system. I'm not going to walk you through each of the components, but the takeaway here is although the power is being generated on the face of the array, there's a lot of equipment to support that array in other places in the ship. In the forward deck house stack, we took a lot of reservations that were in the combat spaces to accommodate that cabinetry, but it does fit. The one thing that, if we have a chance to have Jeff walk you through some of the machinery arrangements, you'll see that the team from the very beginning of the flight upgrade study has always accommodated all of the cabinets with maintenance space, with shock envelopes. So again, this was probably the most robust early stage feasibility study that the Navy has done. One, because we know the platform very well, and two, because we demanded that kind of data from the 3 radar vendors. And again, it was a great interaction with those 3 vendors going through the process. Here you see the evolution of the Aegis combat system. Again, I'm not going to walk through all the changes, but again, that baseline 9 system that will be evolved to accommodate AMDR, and that's really the change between the second and third column, is a very capable combat system. The KEDS consoles that you might know from DDG 1000, if you've been in the mission center aboard DDG 1000, those consoles are going to be on our ships. So, there's a little jealousy in the destroyer fleet trying to evolve that. Any of you that had walked in a CIC of a former Flight 1, 2, or 2A, you might remember that large projector room that had 2 large shock-mounted projectors in it. It dominated the space, the front of the space. That's gone. Now we're using kind of short throw projectors and some LED screens. Allowed us to accommodate a lot more consoles in CIC. We actually took the front row and we're going to sink them down so we get a slight tiered effect to the space. So although we don't quite have the ballroom that's on DDG 1000, the 2-story Mission Control Center, the CIC has evolved greatly. So this is the one-line diagram, and as a naval architect, I'm always fascinated by the electrical engineers, because the biggest piece of this distribution system, of course, is the generators, and the generators become the small circles here and here and here, right? And the electrical system looms large. But what you see there, what you see in black, is the existing 450-volt system. The new 4160 is in blue. So basically, we generate 4160, we step it down and send it through the 2 PCMs to the array faces. All 3 generators can provide power to any of the array faces. Right now, the ship is accommodating a plug at the pier at 450 volt, but there is an option to step that up to 4160. The real reason that was done is most of our cruiser-destroyer peers today are 450, and there's obviously a large bill to upgrade that. So we want to make sure that wherever these ships sail, they can plug in at 450. I imagine as time goes by, as the Navy starts to accommodate laser weapons and rail guns and SEWIP Block 3, all of these combat systems are exponentially more power hungry and therefore cooling hungry than their predecessors. So I think you're going to see all of our future combatants, evolve into medium voltage ships. I just think that's, the way of the future. So this architecture is kind of a hybrid, and it was done specifically to limit change aboard the ship. So the sailors that walk aboard a Flight 2A can walk aboard a Flight 3, and the local load centers will look the same to them. The disadvantage to that distribution system is that we're really only providing 4160 to the radar and with some small switchboard growth for future loads. But the distribution is not as robust or throughout the ship as it could have been. To do that, we would have stepped down 4160 at each of the 450-volt load centers, and that resulted in something like 9 transformers versus 3. So again, looking at limiting change, limiting cost, making the ship affordable. So here you see the electric plant architecture. What I just showed you is the one-line diagram. You see it as big isometrics. We're going to talk to the generator evolution in the upper left. Again, that's provided out to the arrays through the 1,000-volt DC power interface at the PCMs, and then it's stepped down to go to legacy equipment. So again, what you see at the end of the chain there, all the lights, the pumps, the local load centers would be the same as you have on a DDG Flight 2A today. So again, accommodating that new radar, but keeping the ship largely unchanged. This is the ship service gas turbine generator on Flight 3. It is an evolution of what's on DDG 1000. It's a Rolls-Royce MT5 HE+. We did make some slight changes. Time has gone by since the 1000 was architected the MT5 there. So with some engineering, we were able to expand the power output of that plant from 3.9 to roughly 4.2 megawatts, increase the fuel consumption at the same time, so that's a pretty good trick, right? More power, less fuel. The other thing that we did is we removed the sound isolation raft that was required on DDG 1000. She has a higher acoustic requirement than the 51 class, and we had to add bleed air for Prairie and Masker. The other thing you'll note, there's been a little bit of tweaking on the generator to get proper subtransient reactants to work well with both the existing 450 plant and with AMDR. So it's an evolution. It was not identical, but again, from a distance, you'd think it's the same MT5 generator. One of the things that we're working on quite heavily right now up at CES is dynamic modeling of that plant. And so this is I'd say a critical evolutionary area of naval engineering that is going to get increased emphasis, is the interaction between the electric plant and these large power loads. So again, whether it's an AMDR radar, a SPY-6, whether it's railgun, SEWIP Block 3, laser weapon, you're going to hear the same things used over and over again. These are power-hungry combat systems that we have to ensure that, one, we give good, clean power to those devices, and that those same devices, those same combat systems, weapon systems, don't put dirty power back onto the ship. Obviously, in our ship, with the plant split, it may not be as important, but in IPS ships, when you have motor drives, the combat equipment, the weapon systems can actually, cause your ship not to run well. We have an advantage of a split plant here on DDG, but again, to ensure that all these systems run well, there's extensive dynamic modeling going on up at CES right now. Dr. Knopf up there is running that effort. More details on that, and I'm not going to go into great depth. Here you can see the PCM. It's really an evolution of the PCM-4 that's on DDG 1000. DRS is the lead. They got a contract last September. PDR just occurred in March, and we'll have CDR in September of 2015. Again, there's 2 PCMs on board, so a lot of redundancy in the system. One of the things that was done a lot on this ship, and we can't talk a lot about it in an open forum, but is placement of the electrical distribution architecture, placement of the combat system gear to ensure redundancy and to ensure that that equipment's not all located in one place, right, so that there's better survivability of this platform for the future. This is an interesting evolution. Originally, the DDG Flight 2As had a large 400 hertz load. They had to accommodate both SPY, the directors, aviation loads, and that was located in the forward AMR, and we needed that space to evolve the plant. And so what we did is did local integrated power node control, so local 400 hertz conversion. So instead of a centralized 400 hertz plant, we distributed the IPNCs across the ship, greater survivability. So if that IPNC goes down, you don't lose the entire 400 hertz load, you only lose the local load. And so again, evolving the destroyer to be a better destroyer. This is the York 300-ton HESI, high efficiency, small capacity AC plant. It shares use with this as well as LPD-17. If you haven't heard Neil Anton speak, I like to call him Reverend Neil Anton. He's the tech warrant for AC at NAVC. It is religion to him, and he could talk for hours on just the AC plant. But essentially, the amazing thing here is we've been able to get more AC out of the same footprint. And so there's the same story with the generator. And I probably didn't say that well enough. The 501K generators on the Flight 2As evolved in the MT5s. And one of the reasons that we went after that generator was it's single spool, it responds well to large loads. And so really the reason, the serendipity, the reason that Flight 3 can occur is that both the AC plants and the generators are generating more power and more cooling in the same space, right? We didn't have to put extra generators on board. We didn't have to put extra AC plants on board. And so credit to our team in O5Z and again, the folks that support them up at SAS to be able to evolve these plants with industry to provide more power, more cooling, same footprint. Here's the full load operational displacement enhancement system, floaties. But again, what we're really doing is ferrying the lines aft and helping the ship to react in a damage case. Some of the damage cases in the stern. It allows us to grow the maximum displacement. Not that we're going to use all of that today, but again, necessary to provide service life for the future. And again, as a result of that, having greater displacement allows us to put more inner bottom structure in the center of the ship. These ships were not designed for whipping like LPD-17, so this is a nod towards that. And again, more structure down low, better KG. The next two slides are showing you a lot of detail on what we did on the deck house finite element work. Again, early on, we thought these arrays were going to be larger than the final vendor selected, so we were concerned about how we were going to accommodate that. To push the forward arrays down meant they were going to be in the CO's head. We didn't think he'd like that too much, so we were pushing them north, out of the deck house, and luckily we didn't have to do that. But a lot of work has been done. These arrays are heavier, as you can imagine. Again, these aren't just horns on the skin of the ship. There's a lot of architecture occurring there, and you'll see that in a minute. So it is a lot of weight that we didn't have on SPY. So here you see some of the details of how we changed the structure to accommodate the larger arrays, the heavier arrays. Again, this is the slide I told you before. If you take nothing away from this pitch, is to realize how important service life is to keeping our combatants viable in the future fleet. And you can see there the previous DDGs, both weight, KG, power, SLA, and cooling. We've been able to either roughly maintain or in some cases slightly increase what we have on the current ships. Again, great effort on all of our designers and engineers. So that is the end of this pitch. Jeff is going to come up, I think, and tell you about machine arrangements, right, Jeff? Okay. I do have some videos if we have time at the end. It looks like we're only at the 45-minute point, right? If my watch is right. It's hard to be moderator and speaker at the same time. And I can answer any other questions you guys have on 05D2. So, Jeff, why don't you come up, get your slides loaded, Jeff? Okay. we'll have Jeff talk, and then the two of us can try to field questions if you have them on NAVC, destroyers, weather, whatever you want to talk about.
Thank you, Carrie. Good afternoon. For those of you that don't know me, my name is Jeff Merlino. I'm part of the Naval Surface Warfare Center in Philadelphia. I'm standing up here before you with a tremendous more respect for second-string quarterbacks. I think what you're about to see is truly the product of a couple sort of snaps with the practice squad throughout the course of the week. But just to sort of set the expectation, the slide deck that I put together while I was sitting at that table is it's essentially a technical process overview. So I don't talk about any particular ship class in general, but what you'll see as we kind of progress through the slides is that we're involved in most of them that have been on the agenda today. Most of the higher level speakers that you've been listening to were supporting those programs. So with that, I'll just kind of go ahead and get started.
Yep, so you just use that arrow on that side.
Gotcha. Right. Okay, so just what I intend on doing is just telling you really what machinery arrangements is to us, kind of our functional aspects, who we're responsible to, kind of give you an overview of how we approach the problem, the 20,000 foot level of how we take effectively a series of one lines from subject matter experts and translate that into a feasible and working machinery arrangement. I'll talk about some of our key integration considerations, and in that part of the conversation, I think there's a lot of underlying themes as to the overall theme of this session, really affordability, kind of how do we, how are we kept aware of affordable alternatives and what drives cost. I'll let you know who we're supporting and talk a little bit about some of the things that we're doing in the future. So in general, the functional aspects of machinery arrangements really consist of really defining the basic machinery space, right? So we call it the box, the machinery box. It's the main machinery rooms and the auxiliary machinery rooms. It's really how we establish the orientation of the equipment in those rooms. It's how we set limiting dimensions to make sure that we have enough space. It's making sure we have the right number and allocation of spaces, and on and on and on. If you were to take all of those bullets and translate them sort of into a sketch, it might kind of sort of look like this. Right? We're that guy sort of right in the middle trying to keep the rest of the ship from closing in around us. We're functionally responsible to CO5Z. Hassan Pehlevan in 05 is the tech warrant holder for machinery integration and machinery arrangements, as well as energy conservation. And he's our tech authority. So we perform all of the lifecycle tech authority and programmatic and engineering support functions on his behalf. We've had we've been his engineering manager through a formal agreement since 2004, and the applicability of the agreement, incidentally, is for surface ship non-nuclear. So I'm going to talk a little bit about some deviation to that, but officially we're kind of responsible for the surface ship fleet as long as it doesn't have a reactor. And our principal role, quite frankly, is to kind of sort of cross everyone else's swim lane. You know, we look at ourselves as the de facto integrator of the machinery plant. We're always sort of looking at how the machinery affects the auxiliaries and the auxiliaries affect combat and how machinery affects topside, et cetera, et cetera. You know, we recognize as a machinery-centric guy, I recognize as a machinery-centric guy that, you know, our combustion air really affects everyone else on the ship, right? It affects just about every deck, kind of goes from the lowest level or the lowest deck all the way up to the highest level. So the guiding principles that we follow when we put together a machinery arrangement or we're working on a program for someone like Carrie or someone in his group is we try to pre-position ourselves to really quickly react to customer needs, right? Kind of sounds like sort of a business cliche, but you know, as many of you know, we're always being asked to do more with less, and we're being asked to do more with less in less time. So we try to build a process that allows us to get in and get out of machinery arrangements and do some really, really quick feasibility type assessments accurately. One of the big things that we always pay attention to is that we always make sure we're working at the appropriate level of detail. For something like a concept study compared to a contract design, the level of fidelity of the model and the decisions and the choices really isn't as great. So oftentimes we want to make sure that we're not getting caught up in adding more detail that at the level that we're working at isn't appropriate. So the approach we take is effectively a sandbox approach. So what we do is we set up essentially a 3D model that allows us to plug and play, drag and drop, if you will, components into the model do some very quick assessment. If the architectures are changing, it allows us to pull the major pieces out and bring new ones in. So we're always ready to provide chip integration insight to the architecture teams as options are being explored. So one of our big products, obviously, is that machinery arrangement drawing, right? That sketch package. The one that everybody puts in their PowerPoints, and the one that everybody's looking at, and everybody's sort of says, wow, that's really cool. But for us, the big value that we add in most cases is really sort of the integration insight. We like to think that we're a big part of the decision makers being informed as to the decisions that they're about to make. We assess architecture alternatives at the appropriate level. I mentioned that one a little bit more, and we obviously work really hard to be on time and under budget. So how do we do that? We start with the one-line diagram. We kind of walk around and talk with the SMEs, and this one is an early one from Flight 3, incidentally. And then what we'll do is we'll determine, based on this one line, which components are really the critical components, based on, again, on the level that we're working, which ones of these are the ones that we really need to be paying attention to. So we'll take that one line and we'll kind of sort of piece it out, and we'll go ahead and identify or grab the vendor drawings or the space reservations or what other information is available at the time. And then from that, we'll go ahead and we'll create a set of 3D models for each of the components. And of course, one of our big things, one of our big sort of responsibilities, if you will, is to make sure that the ship's maintainable throughout its service life, right? So maintenance access and maintenance windows is a really, really big part of what we're paying attention to, even at the concept level. And then once we have those 3D models, depending on how we're putting them in our different sketch packages and what our customer is asking to deliver, we'll sort of go ahead and sort of make standard projections and kind of use them to sort of drag and drop into the models. So we catalog everything we build. So we have up in Philly a relatively robust catalog of machinery that spans everything from prime movers to auxiliaries and ancillaries to hull and outfitting. We go down to the fire extinguisher level. And what we do is we maintain that, and that's a really big part of how we're able to kind of get in and get out quick. A lot of times, when we're doing these types of studies, as many of you know, you're working with technology that's already sort of in the military inventory, or in a lot of cases, especially with electrical components, some scale version of that. So it's easy for us to go in and sort of grab a power conversion module and scale it to the right dimensions based on the need of the program. And then after we kind of sort of walk through that or get through that, what we end up doing is mapping each of those components to what we consider the critical attributes, right? The MEL, the C-cell, the weights list, all of those sort of critical parameters. And we're doing a lot just recently, in sort of making that connection and making that link. But what we're doing is if we have a 3D model, we don't just have a 3D model, we have a database running behind it with everything that the engineers need to go ahead and assess that in technical artifacts and technical products. One of the things I heard this morning I made a note on is maybe the desire in the future to, or even now, to move from a weight-based costing to a component-based costing, right? So one of the things that I'll be talking about with my colleagues when I get back to Philly is whether or not we ought to be sort of including equipment cost on this matrix. So once we have all of those pieces, we quickly drag and drop the components in, and we make the 3D arrangements. And kind of what's shown up here is a concept study we had done for the LHA class some time ago, but it's a good representation of a machinery arrangement that we would put together. And then from that 3D model, we go ahead and we cut out all of the standard 2D projections that I think customarily we're all familiar to seeing and having routed to us as PDFs and so on. So, in general, that's sort of the overall process from how we get to that one-line diagram to that feasible machinery arrangement that gives decision makers the information they need to assess whether or not an architecture is worth carrying forward, at least from this perspective. Right? There are many other influences into that, and we all know that. Just another example, but the really nice thing about the 3D models is it really provides an affordable substitute to building scale models and mock-ups, right? The way that we used to do things. With virtual environments, with computer-aided virtual environments, caves and raves, if you are familiar with those assets, we have one in Philadelphia, but what we'll do is we'll take our 3D models and we'll walk across the building and hand it to our folks in Code 98, our R&D folks who run a cave. It's actually a rave now. It's a reconfigurable virtual environment. Think of a big room that has video projections on the floor and all of the walls. We could load these models up and scale it and actually stand right inside some of our concepts. It's actually a very valuable tool for us to have in order to kind of just get some sort of spatial awareness and sort of spatial understanding between some of the things that we're putting together. We do a lot of concept development and visualization. We provide concept development support primarily to Kerry and his folks. He's pretty much our primary customer there. But again, it's all about being able to get in quick and accurately. You know, one of the things I'll be talking to Kerry about, and I usually sort of throw this at him all the time, is I'll get a call from Kerry on a Monday, and he'll ask me to deliver something next Friday. So that's just the nature of our business, and a lot of times we have to be able to react to that. And our process allows us to do that, I think, pretty effectively. Good. A lot of visualization, really important stuff. It's really sort of something that we've been more experimenting with more than anything else. But the modeling tools that we use and the software that we use allow us to do some really impressive visualization. So visualization sells, right? We know that. But some of the things that we're doing with the models is like in situations like this where we were assessing very narrow alleyways, we're actually adjusting the lumen levels and the lighting and seeing kind of how that lighting was projecting down on the equipment. So we were fooling around and we're still experimenting with whether or not there's actual real value there. We know once the ship hits the fleet and Soup Ship walks around during trials, they're going to go ahead and sort of, and in an experience-based fashion, determine whether or not there's enough lighting in a particular area of the ship. But these are some of the things that we're fooling around with kind of from an in-office perspective. So just a little bit more visualization. This particular task where the fleet was looking at reconstituting some overhead lifting capability on the LSD class. LSD class, yep. So they asked us to take a look at building some models, particularly of Station 1 of its well, and looking at and assessing a whole bunch of different overhead crane lifting capability, not only for the LCAC, but for the ship-to-shore connector, which you can see the model in the lower right. Ship-to-shore connector, incidentally, sits a little higher when she's on cushion. So considering the impact on the total ship system, and that's sort of, you know, my favorite cliche, you know, it's not about the machinery system, it's about the total ship system. You know, this slide kind of sort of represents what I consider to be the first order of magnitude of machinery arrangement impacts. So at the concept level, these are the things that we're paying very close attention to as we start developing an arrangement. Thermal management, I don't think I have to say anything about that. I think we all recognize exactly how important that is. Power conditioning and energy storage. You know, that's really a big one for us because a lot of times, even now, it's not very well understood in a lot of cases. So for me, the thing about power conditioning and energy storage is no matter what you think you have, it's absolutely going to grow. And we try to plan for that. System control and monitoring, the little things that kind of sort of need to be peppered throughout a space that we typically don't account for or think about. Maintainability, again, it's really sort of our biggest, one of our biggest responsibilities is making sure the ships are maintainable after they're delivered. And that does start at the concept level. OBRPs and special storage, onboard repair parts. For bringing a new system on board, whether it's as a back fit or a forward fit, a lot of times, not a lot of people think of the importance of having spares allocations on board, and that's something that we try driving on the machinery side. It doesn't sort of fall within our rice bowl per se, but we always try to start that conversation because we want to make sure that, again, from a maintainability perspective, there's space allocated for the spares. And cabling and wiring distributives. So this is kind of sort of a visual example of that. You know, what scares me the most is when someone walks into my office with a one-line diagram as simple as this. And this is a waste heat recovery system that consists of 5 major components: a pump, a turbine, a generator, a condenser, and a heat exchanger. And they think that it's really, really easy to integrate this into a ship, right? And what I try to convince people, and if you walk away with any message from this brief, it's really this. It's that when we're looking at things, when we're looking at assessing architectures and systems, we don't quite look at it quite like this. So to kind of sort of put this in a 3D context, right, that might look like this, right? Those are those 5 components. But at the end of the day, you have to recognize that when you integrate it into a system and put it on a ship, it really looks like this, right? It's all of the things that really nobody kind of sort of thinks about, especially early. And a lot of times, unfortunately, too much decision makers are kind of like, that's next design phase. We'll worry about that next design phase. It's all of the things I kind of listed on the previous slide. It's power conditioning, it's special tools, it's firefighting, if there's any firefighting considerations, distributives, replacement parts and stowage, maintenance considerations, and of course, to make it maintainable, we have to make sure that all of the maintenance envelopes stay clear, right? So just to kind of sort of give you typically kind of, the SME perspective, and I no disrespect intended, but the SME perspective of what their system consists of and how simple it is, and really what the reality of installing it on a ship is. So just kind of sort of continuing down that path of integration considerations, exhaust temperature and velocity. A lot of times when we integrate stuff kind of within that system, even if it's like we had done on the Flight 3, the intent was to change the generator, increase its power, but keep the combustion air system the same. There could be some very unintended and severe consequences that need to be addressed, right? Intake trunk size and location, again, combustion air is something that affects every other system on the ship by virtue of affecting every deck. And of course, as the machinery guy, I like my intakes to be extremely straight and open because that's the removal path for my gas turbine, right? I need to kind of sort of rail that up the intake space, and they don't really, they don't do very well with any type of sort of side or lateral excursions as they're going up. Harsh environments of shipboard machinery spaces, temperature and humidity in the main spaces. That's a big factor on equipment design and equipment life. Ship inclinations during operation. By spec, rotating machinery needs to be designed, is designed and shall be arranged with that rotating axis fore and aft. So, when we start seeing people come in and try to sort of put gas turbines athwartship across the vessel, we typically have issue with that, and we try to sort of educate them on some of the concerns there. The right shock grade for the machinery systems, grade A versus grade B. I think probably most of us in here kind of sort of have a good sense for that. And noise and vibration, really sort of preventing that or trying to kind of sort of manage that at the earliest levels. Enclaving and decentralizing is also a big one that we have a lot of conversations about. I think the going in position is that generally at the system level, we try to kind of enclave everything. And by that, I mean put everything together, put everything in the same space. And that might not always be the best answer, again, at the total ship system level. Hatchability, very in vogue, very popular desire to have. But there are times where making something hatchable could be driving unnecessary cost. A good example of that is it's fairly in vogue on a lot of power conversion and power technology now. We want our things to be hatchable because we want to be able to bring them in and pull them out of hatches had we need to repair them. But the reality of it is when we get down to the waterfront and you start talking with repair houses, it's just much more cost effective and much less of an impact to the schedule to just make a shell cut. So those are some of the things that we try to kind of, again, sort of communicate back to folks. And leveraging onboard systems as much as possible. It's the start where you are, use what you have, and do what you can with what's already there. It's never too early to think about logistics. Logistics is a big part of what we do, particularly in the ship alt world. We do get involved in a lot of ship alts, SCDs, that kind of thing. And logistics, thinking about operational procedures, tech manuals, maintenance planning, alterations, system drawings, supply support and testing are all things that ultimately kind of run on the back end of a machinery arrangement or a machinery integration that has a lot of cost and schedule impact associated with it. So kind of our FY15 workload summary, just kind of sort of a pie chart here. We're pretty well diversified. About a third of our workload is RDT&E stuff. A lot of that is new kind of sort of concept development type work. New acquisition support is about 40%. In service, ship alts, ship changes, that kind of thing. There's concept development actually shown there, and then other stuff. We do a lot of specs and standards type stuff. Our cornerstone projects this particular year is we're providing machinery arrangement support for Marine Corps AAV concept that's being developed. The DDG-51 production hybrid electric drive, we're doing all of the ship integration and arrangements for that, working with folks that may or may not be in the room. The Flight 3, Carrie had mentioned, and what we started doing as of last year was providing electrical equipment arrangement support to the Ohio replacement, which is really exciting for us. It's the first time that we've sort of departed from that surface ship non-nuclear kind of moniker and sort of moved into the subsurface arena. We anticipate that at some point we'll be modifying our formal agreement to sort of have the authority that we need to provide that support. So some of if you guys are having a hard time reading that, other than the cornerstones that I just mentioned, we've been helping out with some of the LHA contract reviews, the LXR indicative design. We've done machinery arrangement concepts for integrated power, for hybrid drive, and other propulsion architectures, and provided them to the larger study team. DDG 1000, we're starting to become involved in some concept studies and sort of forward-looking kind of things there. So there's a lot of stuff that we're involved in. Again, a lot of these, I think, are things that we've been talking about throughout the course of the symposium. We did publish Machinery Arrangements Mill Standard. We published this last year, right around Q3. It was a multi-year effort. When you kind of sort of read it, my intent was really for it to be sort of a compilation of all of the things that you ought to be paying attention to in the earliest phases of design from a machinery arrangements perspective. So as you go through this standard, it kind of sort of tells you things about if you have an AC plant in this space, you should also have these types of components with it. So it's a really good sort of overview, it's a pretty good guide that sort of, I think, will clue a lot of you off to some of the things that you really ought to be paying attention to. It's Mill Standard 3045 is the number. We're doing some exploration. We're trying to kind of sort of like kind of automate our process, so to speak. So when you take the flow chart that we use to kind of sort of put together a shipwide machinery arrangement, it's like E size. And that's just sort of a fraction of it there. But what we're looking at doing is trying to figure out how to actually automate it, how to take that process and how to kind of sort of let the computer do some of the work for us to take, maybe to limit some of the iterations or take out some of the options that we may or may not that we may not realize aren't good ones until later on down the road. So that's one of the things that we're doing. And I think that's it. So that's the last slide. So any questions? Mm-hmm. Right. Yeah, so Dave's question is are we capturing execution times? Are we sort of metricing how good we are compared to our estimates? The answer is no, for two reasons. Generally speaking, schedule is the driver in a lot of the things that we're doing. So based on the schedule and the need, we tend to sort of build or tailor our process to meet the needs of the program. All right, so we haven't really kind of sort of seen any value with going back and saying, well, I told Mr. Filling that it's going to take us 6 months to do this, and it took 8 or it took 5. It's not as much of a factor as it is getting him or her the information they need in the time that they need it. I hope that answers the question.
To Jeff's credit, the brief you saw today on Flight 3 was what was approved for Distro A at this function. I'll give a shameless plug. If you come up to the MIT 2N course in Combat Systems Integration, I do a 2-hour lecture on the flight upgrade. And something I realize is missing from this brief is all of the work that Jeff did on all the potential options for Flight 3. So we looked at multiple generator types. We looked at multiple AC plant types. We looked at multiple configurations of those. We looked at 3 generators, 4 generators. We looked at 3 AC plants, 5 AC plants, maybe 6 AC plants, right? So the Flight 3 preliminary design looks like it's very simple, right? It all fit, it was all good. Jeff looked at everything from hybrid electric drive, both in the small HED we're talking about today. He looked at the big LHD-8 drive, where we actually eliminated an LM2500 from the ship. We made a 27-knot Burke, but it was the most fuel-efficient Burke. That Burke would have been more fuel-efficient with AMDR than the Flight 2As today, but our warfighters said, no, we need the speed, right? And I'm not going to disparage any of the SWOs in the room, but you know, if you've ever been on a Burke and she kicks it up and turns 2, speed is a pretty good asset. But for those NavArcs in the room, you all know that 2 LM2500s get you 27 knots. The other 2 get you the rest, right? So it's a very steep speed power curve you're climbing there. And, you know, the Burke, because of her wide seakeeping hull form, tends to push a lot of water at those high speeds. But, you know, so those are the trades we make as a Navy. And again, the presentation I gave doesn't begin to explain all the work that Jeff's team did on Flight 3. What I want to do is stop questions for just a minute, and I want to show you a video on our laser weapon. How many of you have seen the laser weapon at all? Maybe seen a little bit on LAWS. Have any of you seen what's happened on the Ponce and our forward deployed laser weapon? Maybe a few of you. I want to show that video. But before I do that, Paul, can you bring up the slides again? My slides? Sure. Oh, and the other thing I wanted to say that wasn't in the brief, and again, I've probably given about 15 different variants of that brief, and my slides might be a little different than what Rich chose. There's about 24 to 30 DECPs we're looking at. One of those DECPs is for rapid equipment removal routes. If you look at what's going on in the John Paul Jones today and the ships we're upgrading in the field, it takes a long time to upgrade an Aegis combat system today. One of the reasons is to get the equipment out of the ship, you have to move a lot of distributed systems. So one of the things we're looking at is how to route those distributed systems so that there's easy hull cuts and easy hatches to get equipment out of the ship without doing so much torch work. And I think you heard the admirals yesterday talk about we'd like not to use a torch in the future to upgrade our combat systems, and we're making inroads towards that. And we just awarded lead yard and follow yard service contracts to both Ingalls and Bass. So we're going to work with the detail designers, you know, with Jeff's team to look at how we can provide that upgradability. The challenge there is to getting the distributed systems, you know, in the right place to allow for that movement of combat systems. So what I want to show you on the Burke, there we go. Let's stop there, Flight 3. So for those of you that haven't been to look at a Burke at the pier recently, you'll notice that that forward CWIS mount, it's the barbette in front of the forward deckhouse stack, right here. It's empty, right? So the ships were designed with space, weight, power, right, service life allowance for 2 CWIS. We didn't provide that close-in weapon system on the forward mount, largely because we started shipping them to the desert to shoot down incoming Scud missiles. And so we have not populated that mount at the present time, but there is still that space, weight, power reservation. And so I want to show you what we're doing with the Ponce today. What we did is took the laser weapon system and we forward deployed that in theater. For those of you that know the story of the Cole, one of the challenges we have, one of the reasons we made fast, agile, littoral combatant ships is the FAC-FIAC threat is very real, and you saw that in the Raytheon AMDR video. You know, I tend to think of ourselves, the U.S. Navy, sometimes as the redcoats in the Revolutionary War, right? We still like to bring large combatants to the fight, and sometimes march in lines and you know, wear shiny uniforms. And the pirates, the terrorists, the small nation states that don't have developed navies can bring a lot of small threats at our combatants, and it's a challenge, right? So you'll notice that some of the systems on LCS are more designed to accommodate that. And we've evolved CWIS on the destroyers to better accommodate the small boat threat. We've added the Mark 38 chain guns. These are automated chain guns that basically are controlled from CIC, so no longer do we have to have the crew standing in the weather to face those small boat threats. There's 2, they're mounted right about here on the ships going forward to accommodate. So we basically have the sea whiz aft, the chain guns port and starboard. But what I'm going to show you in the video is something that could be used on future destroyers to accommodate the incoming small boat threat, the incoming UAV threat. So both of these threats come in volume, they come in numbers, and one of the challenges we have on our combatants is eventually you run out of bullets. However, we do design our ships to go far across the ocean. We do have operational commanders to keep those tanks full. So as long as you have JP5 in the tanks, you have a laser weapon that can fire. So if we can run that video, Paul, if you haven't seen it, there's not any cool sexy music, but there is some noise. So this is the Ponce, this is the laser weapon coming out of the shed. We basically combined either cutting or welding lasers together to increase the power. There is not a visible light to the laser. You're not going to see a red or green beam. What you're seeing is targets being loaded into the water. And so you've got the control boat on the right and the target boat on the left. And the neat thing about the laser is we can direct energy with a telescope, so we can see that small boat, that UAV, at quite a distance for the operational fleet commander. Here you're seeing the gentleman CIC who's running the laser, looking through that optical telescope. And what he's going to do is he's going to direct the laser energy at the munitions aboard that small boat coming in. So imagine you're a pirate or a terrorist coming at our ship, and suddenly all your munitions blow up. That's a bad day. There you go. You might think about turning around. Again, that's just non-visible laser energy heating up the rounds. So here's another bad guy. He's going to bring a rocket launcher at our ship, so we can see that through the optical telescope. We can focus the energy on that incoming rocket. You can get a close-up visual here. Again, another bad day for the bad guys without firing a bullet, without depleting the magazine. So now we're going to launch a UAV, and we can do two things to UAVs. If they bring optics with them, we can dazzle the cameras so they can't see, which makes them hard to fly. The other thing is we look at the soft parts of all these systems, whether it be the boats, be the outboards, or be the fuel on the wings of the UAVs, or the body, depending on the threat. We heat up the fuel, and another bad day for the bad guys. So that is not part of the plan for Flight 3 today, but it is something that's being considered. And I think it's a pretty impressive capability that we brought to the fleet very rapidly. So with that, Jeff, why don't you come back up, and we'll field any other questions we can on destroyers, the work we do at CES. I think, again, kudos to Jeff on being able to turn to. And you see we have quite an impressive capability in 3D ship design. And Jeff's supported by a team of contractors. I see Jonathan in the room. The Gibbs team is part of that process up there. So again, what you see Jeff and I presenting is a product of a lot of CES work, a lot of contractor work, a lot of shipbuilder work. So we have a great team on our Aegis destroyers.
Hey, Kerry, Jeff, I think you addressed certainly part of it with regards to looking at distributed systems when it comes to removal and replacement of your combat systems. Is that, and the tools you use, have you started to apply that really across the board for auxiliaries and those kinds of things, and given some thinking about even just which systems are closer to the side of the ship in the terms of ease to get things out? And I'm with you on shell cuts sometimes being a lot easier than the hatch piece. In terms of being able to do that. But even for the smaller or larger auxiliary components, that can be a real cost driver if you got to go through cabling and piping and insulation and maybe even some structural support systems and things where you could build a virtual hatch that you could do shell cuts for and still have access to equipment, especially in machinery spaces where density is always an issue. And everything on board the ship, will come out before the life to be
Yeah, I think it's worth mentioning here in response to your question. The process that I think I highlighted was really kind of more of an internal process, the one we use within the Warfare Center to put together the arrangements. But for a lot of the things you're talking about, quite frankly, we rely extremely heavily on our industry partners, right? Our planning yards, our shipbuilders, our defense contractors, because we admit that, kind of sort of in the context of the best athlete for the task. We admit that a lot of times they are the ones to really have that insight and that perspective. So I don't see any of our friends from BIW Planning Yard who I know are here, but Pete McDonald will, he's probably laughing somewhere because of all of the times he's told me, what were you thinking? Right. So I think to answer your question, we think we have a really good understanding of, number one, based on equipment removal frequency or periodicity, how we ought to be addressing that. Size certainly drives it, whether or not it is hatchable or whether or not you need a burp or a warp, an access patch to get it out. And then when it comes to things like distributive impact, we kind of sort of turn to our industry partners and ask you all for help in really sort of understanding kind of really what the best options are for that.
Yeah, it seems to me, a lot of, discussion over many years has been given to life cycle, total ownership cost. If you could take 25 to 30% off the cost of replacing something during the maintenance period and maybe shave some time off too by thinking ahead and running the cabling all in one area so that you don't have to break that cabling to get something out that you know is going to come out,
Right.
within the first probably 20 years of the life of the platform. You've just saved a bunch of money, and if you aggregate that across all the auxiliaries and components, you might really have some true life cycle cost savings that make it worthwhile to pay attention to it. And I agree, maybe that's not in the governmental pool in the sense of the thing, and besides the way they build the ships, to some degree stick-built, even with the best 3D type things.
Sure.
But paying attention to that, I think, is a way to drive some cost down the life cycle.
Yeah, there's no question it should be a government consideration. There's no question about it. It's a bit of a very, very difficult paradigm shift that needs to occur because right now we're weight-based and we're compact and smaller is better. When in fact, subjectively, there's plenty of things out there that you could look at to say, wow, if I just had a little more space here, if I could spread that out just a little bit more, it's a straight shot. I'm not removing all of this stuff. So, yeah, it's something that we try to address as best we can. I think we could do a better job.
The other thing I'll say is all of the SESs in CO5 are being incentivized to strongly look at affordability. That goes into their end-year assessment. And so that's flowed down to all the tech warrants. So all the ship design managers and all the tech warrants in 05P, H, Z, W. So if folks have good ideas, and it can be either a cost savings or a cost avoidance, there's certainly a great appetite now to maybe, I'm not saying we've turned a blind eye to it before, but I think obviously given what you heard this morning from Secretary Kendall on 10 years of sequestration, any way we can continue providing that warfighting capability at a more affordable cost, that's a big focus. And again, what you didn't hear today from the frigate team and the LXR team is a great focus on affordability on those new ship platforms as well. And there's a lot of discussion and a good dialogue between the fleet operators, between OpNav, between NAVSEA, on understanding the cost versus capability trade, probably more so than we've ever done before. We're having an open dialogue on what do requirements really cost, what requirements are important, trading, and it's hard. We don't always get the ship we desire because of the cost constraints we have right now. So, any other questions? Yep.
First off, well, this last presentation, it sounded like that was not part of yesterday. Will that get added to the proceedings? Because it was pretty interesting as far as the machinery arrangements.
Yeah, so it's distro. We'll make sure it gets added.
Okay.
Yeah.
And
again, thank you to Jeff for turning two. So.
Yes. Yeah, because machinery arrangements is something I think a lot of times there's probably more general arrangements out there the documentation of machinery arrangements over the years hasn't been kind of a black art, it seems like sometimes.
And the other thing I'll say real quick before you ask the question, I don't know if Jeff mentioned this, the other thing that's very important, again, another takeaway on what we did right on the cruisers and destroyers, the hot plant that exists in Philly. And I don't know how many folks have walked LBES with the land-based engineering facility up there. Basically, Jeff can walk out and touch every gas turbine generator from the 2 megawatt cruisers eventually up to the 4.2 megawatt generators on Flight 3. There will be a Flight 3 hot plant at Philly. It will include 2 generators, PCMs, and it can tie into the existing hot plant. That is a invaluable tool, and I need the naval engineering community to shout that to our leadership. There is certainly a thought that hot plants are a waste of time, that we should do all of our testing and commissioning at the waterfront. I'll tell you, that's not a recipe for success. The hot plant at Philly has allowed us to take ownership of the machinery control system aboard our cruisers and destroyers and deal with obsolescence issues. Anytime a part goes obsolete in machinery control in the plant, we can actually replace that part in the hot plant at Philly, change the machinery control to accommodate that new part, and ensure it works before it goes to the fleet. And there's a reason that our Arleigh Burke destroyers have a high operational availability because of our ownership of that machinery control and because of that hot plant. So again, as we all work on future programs, that is a recipe for success to have a hot plant ashore. It's a cost, to be sure, but to maintain that for the life is invaluable for the program and makes us have better combatants. So go ahead, Sean.
Okay, the other one was a question or maybe a suggestion, if it's not being done, on the backfit. As you're doing these studies on how to do the rapid equipment removal routes, and it seems like I think, aren't we already doing that with HM&E? Isn't that kind of already been defined already? I think it's a spec requirement to have equipment removal routes.
Yeah, there's an access control program
Yeah.
that's required by spec typically
Yeah.
that delivers a whole bunch of equipment lists and removal paths and drawings associated with it.
But
most
it
of it's-
seems to me, but I think the new focus seems to be supporting the combat system upgrades. And my question was, okay, so you're doing that, is there any thought to saying, okay, yeah, we're doing modernization now, but maybe, those ships are gonna get some other things, so maybe see, is there anything you can do as part of those alterations to go ahead and implement? You may wanna look at, if you haven't already, as you define those, is there any interest in backfitting some of those paths into the existing ships as part of the modernization program to facilitate future upgrades?
That's a good thought. I can say it's not currently planned, but there is a robust dialogue between PMS 400D and PMS 400F and C21. For those of you who don't know the PMS structure, basically, 2 captains, one Captain Vandroff responsible for forward fit, and PMS 400F and C21 responsible for modernization. Every time we hold a configuration change board, and there's annual configuration change board for every multi-year, and then there's monthly minor ones, but we always have the C21 folks there, and there's a robust discussion that occurs between the 2 captains about what we can backfit. So there's always a drive to do that. I think the challenge that we probably all face in all of our combatants, whether it's a cruiser, destroyer, or amphib, is, as things get added to the ship, keeping those paths clear, right? So I think, you need to designate that path, and then, if it's the hull cut, it's the burp, it's the warp, it's keeping growth from infringing upon that. And, as we know, that's challenging to keep those maintained, but it's important because, one of the challenges today is that the modernization costs are high because of the amount of torches required to get the equipment in and out.
Well, my suggestion is, once you define those, that maybe even, they might be applicable to the current ships that are going through modernization, and it may be worth paying a little bit more to move some of that cabling or piping, or put in, in case maybe flanges, and, define that work, so that, because they got to make those cuts anyway.
Yep.
And maybe it's only a few more dollars, and it'll cost a few more dollars now, but maybe the type commanders will recognize that, and 400F will recognize, hey, it'll save us money 5 years from now, the next time we have to do a combat system upgrade.
Absolutely. And again, for those of you that are maybe not familiar with the NAVC team, I have 2 SDMs. Pat Potter is my Flight 2A SDM. Walt Mebbin's the Flight 3. But they also have a peer and comrade in Fred Sal, who's the in-service DDG SDM, and we have in-service cruiser SDMs. Most recently, it was Glenn Grogan. He just moved over to LPD, new construction, and his position will be filled. So there is a close dialogue there as well between D2 and D5. Denny?
Just, it's impressive to me to see how far we've come in terms of machinery arrangements and so forth and the capability that we have. I mean, the way you're doing it now is kind of almost taken for granted, but I was head of the propulsion group in NAVC. Hard to believe it was 30 years ago, but when we were doing the original design for DDG 51, and we had the machinery arrangements group was in my group at that time, and we did the machinery arrangements mostly with manual layout in 2 dimensions. And all of that was done, all the initial studies and trade-offs and so forth were done in that form. And then I was CO of NAVCES when we built the land-based site. And we found a number of interferences, significant interferences, that we had to get corrected while we were building that. And when we had the dedication of that site, that we had the shipyard executives there, they told me that the interferences that we found and corrected because of the site saved several months in delays and several tens of millions of dollars in cost just by having that site, even just for the erection, not even let alone for what we gained through the testing.
Absolutely.
Yeah. Just first, I just want to say thank you because even though it was 30 years ago, right, last century, if you want to say that, I think you would really be surprised.
No offense, Denny.
Yeah, right, yeah. No offense, Denny. I really think you would be surprised if you sat down and actually really interrogated our products, how much of it is really born from the work that the guys like Herb Farrington and Russ Rollison and other folks in that group, all Greybeards now really had done. So thank you for that. Thank you for setting that foundation. And the only thing really that I want to add about the test site, Carrie mentioned it and now you mentioned it, is our test site folks are really fond of saying it's the fleet's ability to put something to sea before you put it to sea.
Absolutely. Yeah.
And it is this absolutely great resource. When I'm fortunate in that I have a group of very young engineers working with me doing machinery arrangements, and when they come into the group, the first thing they get is a pair of steel toes and a measuring tape. Because to be able to walk over to the test site and sort of measure exactly how much door swing you need on a piece of a component is an unbelievable resource to have.
And again, Jeff's capability to deliver rapid concepts is certainly amazing capability. And unfortunately, a lot of times we're pressurized to deliver decisions quickly in short duration. And again, that was an invaluable resource. And Jeff was a real partner in the flight upgrade effort it was 2 funded years over 3 calendar years. So a lot of things were considered, and we certainly appreciate that capability. I think we're at time at 1500. Denny, do you have any update on the program from here?
We will have at least part of the space panel, space technology panel, at least 3 people here in about 15 to 20 minutes.
Okay.
And these are people, it's basically the high-tech space industry, the group that's now building the space vehicles that are going into space and carrying U.S. payload to the space station and so forth, and doing the experiments for the future. And they're going to come in and talk about what they've seen in terms of technologies, new technologies that they're developing that may have potential implications for naval engineering.
Okay, and we're going to do a coffee break outside here?
We'll do a quick
okay. Well, again, I want to thank all of you for your time and attention in, again, proving yourself worthy attendees like all of our hardy shipbuilders up north at Bath and Marinette who, again, show up for work every day when it's 20 degrees or minus 20 degrees with snow and ice. And I appreciate your ability to accommodate our change, and I will push hard to get LXR and the frigate presented either at a flagship presentation or at a future ASNE event. So with that, we can answer questions, I guess, till SpaceX comes. If you folks want to go out and get coffee, I wouldn't keep you from doing that. Do we have any other questions or concerns?
Quick question. You make it seem that integrating AMDR into DDG is not easy, and they've used up a lot of margin. I guess two questions. How much margin is going to remain? And number two, is this going to be a harder ship to build? Is it going to be more dense than a DDG Flight 2A?
So I showed you the SLA in that one chart with the Gantt chart, and again, we were fortunate that we could basically increase the generators from 3 megawatts to 4.2 megawatts in the same footprint, increase the cooling plants from 150-ton plants to 300, and the reality is, given the requirements of the DDG, those will actually be probably pushing 350-ton plants. So, you know, exponential growth in power and cooling without more footprint. What was challenging, and again, Jeff and I have briefs we could show you walk you through each of the machinery rooms, and that wasn't in this brief. The electrical distribution for 4160 is not insurmountable. That's a lot of boxes going into the machinery space. Again, we were able to accommodate that slightly by getting rid of the 400 hertz centralized plant. We were fortunate that we're not accommodating AMDRX up front. AMDRX, the one we looked at as a phase array, was going to be pretty power hungry and require a fourth generator. That was a lot more challenging. You know, I think in general the ships are about as crowded as they were. Would you agree?
Yeah, I would agree. Looking at DDG 51, I guess as a comparison point, it's probably a little bit more crowded, but certainly not as crowded as some of the other ships we have in the fleet. So it's within what we would consider to be the acceptable range of, you know, density.
And because what we did with the lines aft and the new structure down low, again, we have just as much weight and kg margin as we had in the current ships. Again, credit to how the ships are delivering today. The shipyards today are delivering those ships at about 0.7 foot a kg, and they're over 10% on weight. So the ships today are being delivered essentially light. So again, very effective shipbuilding at both yards. Helps when you build, 62 ships and counting. So, they've gotten pretty effective at that. So I don't think you're going to notice a big difference if you walked aboard. SPY took up a large footprint too, so ripping out SPY and AMDR, it's a pretty good trade. The one thing I didn't say in that pitch is, and again, because of looking at different slide decks, they're architected differently. The AMDR arrays are made up of 37 radar modular assemblies, RMAs. Each of those 37 arrays is a radar unto itself. So the array is very self-healing. Each of those arrays could operate unto itself. Within those, and each of the vendors were driven to common solutions, there's only 4 LRU types in those arrays. So you can pull out the components and heal the array very quickly. So there's not as much work will be done with a soldering iron on the ship as is SPY today. It's really pull out a card, replace a card type mentality. So the array uptime and the array self-healing is pretty impressive. So again, I think we're going to see a far better, more operational radar in the future.
Couple questions. Respect to laws, do you have any thoughts as to the difficulty of integrating it? Is it kind of like phalanx or CRAM where you give it a target and then it goes off and does its job, or is it something, the more difficult things like a gun where you actually sort of have to, the combat system has to extensively interact with the weapon?
The laws today is a pretty self-contained system. As you can see, it still requires a console, so we have to put a console in CIC, and we have the growth for that. We actually have 2 consoles worth of growth in CIC. But essentially, it is fairly self-contained. It wouldn't have to be integrated with Aegis. There probably would be some advantage to passing tracks from Aegis to LAWs. Today in Ponce, it's a standalone system. My understanding is that system will eventually, what you see there is largely a developmental system inside the government. Obviously, the mount work was done by Raytheon because it's based on the CWIS mount. I think eventually that will be a competition that's competed amongst, there's other competing laser systems. They're all similar. So I think it's easily accommodated in what we have available on that forward mount. and that's why I'm excited about it. I think it's a great combat capability with not a lot of ship integration challenge.
One of the niceties of that is that you can actually put it on ships that don't have a combat system. And the other thing that's nice about it, as I mentioned, is, CWIS is great, but it's also very problematic because if you're going near shore, you have to turn off CWIS because the potential for fratricide or taking out friendlies or neutrals or just because you'd like to be invited to that country again may force you to turn it off because of where all the bullets that don't hit the threat go.
Right.
And one of the nice things about this kind of system is it's only hitting what you're pointing at. And so that makes it suitable for things. There were some discussions where people are talking about putting a railgun on a joint high-speed vessel, which is not appropriate. But on the other hand, something like laws, other than its cost, would be very attractive because you could actually, go into brown water and use it without worrying about not being invited to that country again.
Right, right. And again, the optical telescope that comes with laws is a capability, and I unfortunately I don't have the range memorized on the telescope. But if you look at the electronic optical cameras we have on the roof of DDGs today, if you've ever been aboard a ship and know, we tend to track all the vessels around the ship optically, and the optical telescope has far more capability than what that optical camera does today. And the ability to discern who's out fishing and who's out to do harm is a great advantage to the operational commander. So I think we'll see it fielded more sooner rather than later, and it's proving itself on Ponce today.
The other question is more of a curiosity question. You're using the Spook 9B with the integral IFF, and I guess I'm sort of wondering about that because the DDG has the centralized IFF system. Can you kind of explain why there's another IFF system on board in effect, rather than using the IFF identifications coming from the centralized system?
I'm not sure I have the answer for you. I think I used to know the answer to that, but I'm not sure I have it on the tip of my tongue. So I could certainly get back to you on that.
Just kind of curious because
and I recall the discussions, but I don't recall the solution. So do you recall? No, I don't. Yeah.
The issue you run into, the reason why they generated a centralized IFF system is they wanted all the weapons to have the same IDs so that you wouldn't have some thinking this is a friendly, some thinking this is neutral. If you're going to make a mistake, let everybody make the same mistake.
Right.
And so the issue was kind of how we ended up having both a centralized IF system and a local one, and how you deal with what happens if they come up with different answers.
Right. Right, and I recall the conversation. I just don't recall the solution, and maybe I haven't heard the solution yet. There was talk of whether we keep the centralized IFF antenna up on the mast or use what's coming on Spook 9B, and I don't recall the answer. So, unfortunately, I have to get back to you on that.
Okay. Well, obviously, the centralized one is incredibly expensive, but that's because of it's like a $5 to $10 million system. Well, what you have in the Spook 9D is probably the order of $100,000. So it's a big cost difference, that's for sure.
Right.
Thanks.
Right. All right. Anyone else? All right. Well, again, thank you for your participation and hanging out in the snowstorm with us. We'll clear the stage and get ready for the space panel. And again, coffee should be outside. Thank you.